Hello everyone, we are Team 7. Our team includes Kanchana, Nouman, Raisa, and Ewurama. It is estimated that 3.9 million people face the hip fracture annually, and three-quarters of these hip fractures are in women. Hip fracture range in top 10 worldwide in terms of the disabilities and functional decline. As from this figure, you can see clearly that there are various sites of fracture due to the impact of the force. There are certain consequences that can be found with the fall, that is loss of neuromuscular function, more difficulties with daily living activities, increase in cognitive deficit, increase in depressive symptoms, and changes in social function. And in the severe condition, it causes death.
Some of the current designs in the market include hip pads, traction socks, and smart canes. Hip protectors work by either absorbing or dispersing the impact energy away from the critical area, thus saving the bone from breaking. But they're heavy, bulky, and difficult to use. Traction socks are used as footwear in hospitals, but they require regular changing and removal before transferring to bed. Smart canes have a self-balancing mechanism, but they're also very heavy and easily forgettable. We introduce a new hip protective solution that protects patients from fall-related hip fractures. This smart belt uses current STF technology packed as a belt designed with predictive analytics to measure pre-established outcomes. The smart belt is offered to adults as a clothing accessory, providing a wearable safety solution against hip fracture. This product targets lower middle income countries with a higher percentage of total population over the age of 55. This includes countries like the Philippines, Vietnam, Cambodia, Bangladesh, Pakistan, Nigeria, etc.
Our design is a smart external hip protector that can detect a fall and react in a way that protects the user from the impact. The main components of our design include an accelerometer, diaphragm pumps, shear thickening fluid storages, pouches, and cushioning foam. Initially, when the user is in a stable position, the pouches will remain unfilled and flat. However, once the user falls, the sensor will detect the increased downward acceleration, and the pumps will push the shear thickening fluid into the pouches. The fluid is able to thicken upon impact, efficiently distributing the concentrated force acting upon the hip bone. The foam underneath the pouch will act as an impact absorber, which decreases the fall impact even more. Once the user's acceleration is back to normal, the pumps will suck the fluid back into its storage. Our prototype was first sketched in AutoCAD, then imported into SolidWorks